First question, how many primary, secondary, tertiary and quaternary carbons are present in the following hydrocarbon? Now first we have to draw this structure in an open chain or a complete molecular formula. So first this CH3 as it is, then this CH is having a branch of the CH3. So there's one CH with one branch of CH3. Then there is this C attached with two branch of CH3. So this carbon is attached with C with two CH3. Then next there is CH2. Next there is CH with one branch of CH3. So there is CH with one branch of CH3. Next there is CH2 and there is CH3 at the terminal. Now we have to find the primary, secondary, tertiary and quaternary carbons. Now first of all, what is primary carbon? The carbon which is attached to only one carbon atom. Okay, so this is one primary, this is one primary, this is primary, this is primary, this carbon is primary and this carbon is primary. That is the CH3 groups. Next is secondary. So secondary carbons are the carbons which are attached to two other carbon atoms. So that is this group. If you see this carbon is just attached with this carbon and this carbon. So it's a secondary carbon and this carbon is also a secondary carbon. And thus there are two secondary groups. Next, the tertiary one. So it's CH group. The carbon which is attached to three other carbon atoms. So this carbon, if you look carefully, the CH is attached to one CH3, one C and one more CH3 group. And similarly here also, this CH is a tertiary carbon as it is attached to one CH2, another CH2 and this CH3 group. And the last, quaternary carbon, where the carbon is attached to four other carbon atoms. So if you look at this carbon is a quaternary carbon because this carbon is attached to one CH, one CH3, one CH2 and one CH3. So this carbon is a quaternary carbon. Now if we'll count 1, 2, 3, 4, 5 and 6. So there are 6 primary, 1 and 2. There are 2 secondary, 1 and 2. There are 2 tertiary carbon and this only 1. So there is 1 quaternary carbon. So the correct answer among the given option is 6 primary, 2 secondary, 2 tertiary and 1 quaternary. That's option A. Next question. Naphthalene is an or is O. So naphthalene is a molecular solid. If the crystal cation only individual atoms as in solid argon or krypton, or if they are composed of non-polar molecules. As in naphthalene, the only attraction between the molecules are the London forces. And the correct answer is option D, that is the molecular solid. Next question. Which of the following is not aromatic? So according to Huckel's rule, a compound is said to be aromatic if it is planar and there is complete delocalization of pi electron, which is only possible if it is conjugated and cyclic system. And the number of electrons used in delocalization should be 4n plus 2 electron. So these are all the properties of the Huckel rules. Now among the given option, A is benzene and the structure of benzene is this. This benzene is a planar structure, have conjugate double bond, cyclic system, pi electrons, and have 4n plus 2 electrons. That if I count, n is equals to 1 for benzene, okay, 4 plus 1, 4 into 1 plus 2, that's equals to 6. That's 6 electron. Option B, that's naphthalene. So the structure of naphthalene is this. It is also a planar structure with pi bonds, conjugated, and a cyclic system. And the number of electrons, so here there are 2 rings and thus n is equals to 2. So I can put 4 into 2 plus 2. So that is 4 to the 8 plus 2, that is 10 electrons. And this 1, 2, 3, 4, 5. 5 double bonds counts to 10 electrons. And thus it is also aromatic compound. C option, that is spiridine. The structure of pyridine is this. It's a cyclic structure with conjugate double bond system. It's also a planar structure and also follows this 4n plus 2 pi electron rule. Next, if you'll see the option D, that is 1, 3, 5 heptatetraene. So we are supposed to draw first a 7 carbon ring. Suppose if I start my numbering from here, 1, 2, 3, 4, 5, 6 and 7. And double bonds are on 1, 3 and 5. So it's a cyclic system, no doubt. There are 3 conjugate double bonds. But if you'll see, this carbon is not present under the conjugation system. Okay, and because of that, this molecule is not aromatic. This carbon is sp3 hybridized and it undergoes the tetrahedral angles. And because of that, the structure is also non-planar. So the correct answer among the given option is option D, that is 135 heptatetraene. Next, which order is correct for decreasing reactivity to ring monobromination of the following? So first of all, we are supposed to write the structure of this given formulas. C6H5CH3, that's nothing but a toluene. So it's C6H5 and there is one CH3 group attached. Next, that is C6H5COH. So it's a benzoic acid. COOH. Next, C6H6. It's a simple benzene. And the fourth, C6H5NO2. That is nitro group. Or you can say nitrobenzene. Now we know that this CH3 is electron withdrawing group. So its reactivity is very high. So since the number is 1, 2, 3 and this 4. So this one will be having the highest reactivity towards the monobromination of the compound. Okay. Then the next, if you look this, this one NO2 group. Yeah. So if you look at this COH group and this NO2 group, those are electron donating substituent and they decrease the reactivity. And this benzene is in between them. So first the reactivity of the first toluene is very high. Then it's benzene with no group. Then it's benzoic acid with COH, a carboxylic acid group, electron donating substituent, and a very strong electron donating substituent, that is a nitro group, that's 4. So this is the reactivity to the ring monobromination of the compound. Among the given option, the correct answer is first, third, second and then fourth. Option B. And the last question, In benzene, 1, 3 position is called. So first of all, we need to know that this is a benzene structure and there's this alternate double bond. Now, if I put any specific functional group, suppose X over here. So now X has the number 1, the carbon attached to X is 1, then 2, 3, 4, 5 and 6. Now with respect to X, these two position is ortho. These two positions are called as meta. And this fourth position, opposite position, is called to be as a para. So the question says benzene 1, 3 position. So 1 and 3 position is called as meta. So the correct answer among the given option is A, that is meta.